Productive nanosystems, from molecules to superproducts. Final production made possible by a challenge grant from Mark Sims and Nanorex Incorporated. Future advances in molecular nanotechnology will enable desktop appliances to manufacture products far better than today's best. The cartridges to the left supply simple raw materials to the machinery inside, here shown in schematic form. Products emerge from the top of this box, which holds the heart of the manufacturing system. Each product is built from beneath, layer by layer, by billions of tiny machines all working together. Near the top surface is the productive machinery itself organized into layers. Machines in the lowest layer process molecules into building blocks, passing them upward to machines that assemble them into larger components, and then to machines that add these components to the product. From a millimeter scale, 1 million nanometers, our view zooms in to the 10 nanometer scale. Each box is 1/10 the size of the one before. Here, at the molecular scale, nanomachines make small building blocks from molecular raw materials. The first machines sort molecules by their size and shape, passing some, rejecting others. Only molecules of the right kind can enter the processing machinery. These molecules contain 4 atoms, 2 of carbon and 2 of hydrogen. The molecules bind to a device that carries them to the next stage. Then, a rotating mechanism swings tool tips into contact with the bound molecules. Each tip presses a molecular tool against a molecule, bonding it firmly. The tools shown here have been analyzed using advanced quantum chemistry techniques. Another tool moves in from the left to remove the hydrogen atoms, leaving a pair of carbon atoms exposed and ready to use. The tools then carry these atoms to their destination, where each pair bonds to a nanoscale building block, making a tiny bit of crystalline carbon, a bit of diamond. Motions happen quickly at this scale. This scene shows motion slowed by a factor of more than 1,000,000. A conveyor carries the blocks past further machines, which build the blocks step by step to full size. Elsewhere, other specialized machines build blocks of different kinds. A system of conveyor belts and transfer mechanisms carries completed blocks from where they are made to where they are needed. This transfer mechanism moves blocks from one belt to another. The transportation system carries many different kinds of blocks, different shapes, different materials, different functions. It delivers them to the next stage of manufacturing. Here, a programmable machine lifts and places small blocks to make larger blocks. The small blocks bond on contact to form components containing millions of precisely arranged atoms. These can be simple structural bricks or intricate components for mechanical and electronic systems. The completed components are delivered to the final assembly stage, where many machines work together to build the final product. Motions at this larger scale are still quick. This scene shows motion slowed by a factor of 10,000. At the base of each machine, a transfer mechanism grabs components and lifts them from a conveyor. Each is flipped around, then carried up to the underside of the product under construction. Finally, machines lift the components and plug them in place, adding layer after layer to the bottom of the product. When the last layer is finished and construction is complete, the product is ready to be removed and used. The result of this production run is an atomically precise multiprocessor laptop computer with 1 billion times more processing power than today's best. The only waste products are warm air and pure water.